Hi all, in this video lecture, we'll learn about the fork system call. Fork system call is used for creating the new process. So here, the parent process will be creating the child process. The fork system call, which spawns a new process, is called child process. And after the child process is created, both the parent process and child process will run concurrently. After a new child process is created, both the process will execute the next instruction following the fork system call. A child process uses the same program counter, same CPU register, and same open files which is used by the parent process. That means the child process shares the resources of the parent process. So example one, just to have the experience of what is the how this fork system call is used. And for using the fork system call, we need to include the header files / types.h. So here we have the fork system call. After the fork call is being executed, both the parent process and child process after will be executed. That is, once a fork system call is invoked or called, a child process will be created. So now we'll be having two processes. One is called parent process, other process is child process. So we'll see how these are executed. Here in our example, we have only printf hello world, but we'll be getting this line being executed twice. That is once by the parent process and the other is by the child process. We'll see them with an online compiler. So here we have the code, int main for printf hello world. So if we could run the program, you could see the hello world is being printed twice, once by the parent process and the other is by the child process. So going back to the content. A fork function call does not take any argument and return one integer value. But the question is, to where this will return? It will be returning for 0 to the child process and a positive value to the parent process. That the positive value is nothing other than the process ID of the child process. We all very well know whenever a process is created, a process ID will be unique ID will be generated as by the operating system. So here the 0 will be returned to the 0 will be returned to the child process and a positive value, which is the process ID of the child process, is returned to the process parent process. And there is a possibility that the negative value also will be returned to the parent process, that is on unsuccessful creation of the child process. If the fork is failed, at that time we'll be getting the negative value. So next question is, if we run the fork for one time, we'll be having two processes, that is one parent process and the other child process. And so when we invoke, in this example, we have called the fork system call for 3 times. Then how many processes will be there at the end after the execution of the third fork system call? So first, two processes for the first system call, we'll be having two processes. And when we execute at the end of the second execution of the fork system call, so each child will create, each parent and child will create 2 more processes. So we'll be having 4 processes. When we invoke the third time, for the fourth time, sorry, for the third time, we'll be having each of the 4 processes will spawn one child process. So totally we'll be having 8 processes. Suppose we invoke for the other time, one more time, that I mean the fourth time, the 8 parent processes will be there. So 8 parent process will spawn 8 more processes. So totally we'll be having 16 processes when we run for the fourth time. So in general, if we talk mathematically, the total number of process created by the fork system call is 2 to the power raised to n, where n indicates number of times the n. Number of times the n is invoked. number of times the fork is invoked. So we'll see how these values are returned. As an example, so here the code is, main fork ex1. We have the main function. The main function calls the fork ex1. This is an example code. Inside the our example code fork example 1 code, we have invoked the fork call. If the fork returns 0, which means the child process, the execution is child process. Otherwise, that is, if it is positive, then the parent process is being executed. So we'll run the code. So first, in this example, the first for this execution, we should put the word rightly. For this execution, the parent process is executed, and then the child process is executed, as you could see from the output. So the order of execution, whether the parent process will be executed or the child process will be executed at first, is not defined. So the order of execution of the parent and child will vary at different point of time. So going back to have the experience that how many times the fork how many times the how many processes will be created with respect to the number of times the fork is invoked. So in this example code, we have invoked it for 3 times. That means we called it for 3 times. Then there should be 8 processes. So the process execution, we just have only the code T2 section. So the T2 section will be printed 8 times by the 8 processes. But each of the processes is executed only once. So that is it. So next, one more point we said while studying, introducing the fork, the parent process and the child process will share the same CPU register, same open files. So if CPU register or say same memory or same virtual pages are shared, then there is a problem called data inconsistency, that one process will try to modify the value updated by the other process. So to avoid that, we have one thing called copy on write. So in this example, we look into that. We'll concentrate on that. So this example illustrates how the parent and child process use common memory. So here, we have, in this example, we have invoked fork for 1 time. So there is 1 child process and 1 parent process. So the parent, we have the common variable which has been shared by the 2 processes. X is equal to 1. So the parent process is decrementing the value of X, whereas the child process is incrementing the value of X. So here, important point to be noted is copy on write. So we know, right? So when one process is trying to modify the value of the other process, shared value of the other process variable, then we have to be carefully handle this incoherence issue or inconsistency issue. So the OS has a copy on write facility. When one process is modifying the, or modify means when it is trying to update or write the content of the shared variable, at that time a copy on write call will be invoked. So that copy before the write will be updated, will be used by the other process. So in this example, look at carefully. So when fork is equal to 0, the child will be executed. We have already X is equal to 1. So X will be incremented by 1. So we'll be getting the output as 2. And here the value is X. So since it is a common variable, it is naturally we can assume that X value will be printed as 1. That is 2 minus 1 will be getting us 1. But it is not the case because it will be using copy on write. So when the child process is trying to modify the X value, before modifying the value, because it is a write operation, on write operation, it will copy. So that is the work of the copy on write protocol. So we'll have the we'll experience that also through execution. So you could see the parent has X is equal to 0 because X is already 1. So when it has been executed, the minus X is decremented. It shows only X, and the child is just incrementing. So that is the role of copy on write, and how this inconsistency issue or shared memory problem is resolved using copy on write protocol. So we have discussed about what is fork, what are its return values, how many process will be created when a number of times fork is invoked. So next is how to get the process ID. Okay, so we said that fork will return the positive value to the parent process and a 0 to the child process. So positive value, we said it is the process ID of the child. So how to get the process ID of my own process? So the get PID gets the process ID of the current process, and get PPID gives the parent process ID. So we'll execute that also so that we'll have a better idea. So here we have the code. Look at the code carefully. I have int main, and into the main I have my PID, my PPID. My PID is current process which is in execution, whose PID will be stored here. My PPID is my parent PID will be stored here. For these, the data type is P underscore T. This is the data type. And we are calling the PID is equal to fork function. The fork function will return a positive value to the parent process and 0 to the child process. So we know that, right? So if PID is equal to 0, it means the fork failed and return 1. So then if PID is equal to 0, which means the process is executing the child process. So if PID is equal to 0, the child process is being executed. To print the process ID, I just have get PID. We are using the process get PID to get the current process ID, and to get the parent process ID, we are using the get PPID. And this line, the 20th line, just prints the current PID and current process PID and the parent process ID. Else condition is when PID is greater than 0 and we are introducing a sleep so that the child process may terminate until we are waiting for to terminate it. And this is the parent process, and we have my PID is equal to get PID. That is, the parent process is printing its PID, and the parent process of the process ID of its own parent process. So we'll execute. And so we have introduced a sleep 2. So 2 milliseconds, this will be, the parent process will be waiting. So now, let's clear for line number 13. Sorry, I have kept it off. Yeah. So now the child process is being executed and the parent process is executed. I am executing it again for better understanding. So you could see the sleep time and then the parent process is executed. So you could see the process ID of the child process and its parent process. And process ID is 39835, the parent process ID. I could cross verify. The child process parent is 39835. Okay. So, and the parent has its own parent. So that ID is 39828. So in this video lecture, we have just seen what is fork, what are its return value, how many times how many processes will be created on with respect to the number of times the fork is executed, what are the values, negative value, positive value, and the zero value, and the meaning for them. And then we have seen the how to print or how to access the process ID of current process and how to get the parent process ID. Thank you all.